Hey, hello and welcome to today's GFG problem. The day uploading well. So let's say today's problem Stickler Thief 2. Okay, so what the promising is we'll be given an array. Okay, let's say the array is what? 1, 2, 3, and 1. Okay. And which represents the houses arranged in a circle where each house has a certain value. A thief aims to maximize the total stolen value without robbing two adjacent houses. Okay. So determine the maximum amount the thief can steal. Note, since the houses are in circle, the first and last houses are also considered adjacent. Okay. So here we have been given an array and each element represents the total amount, represents the amount present in a particular house, in house 0. In house 1, it represents the amount of value 2. Then in and so on. Okay. Okay. So this is the array, and we have been asked that there will be a thief who will steal the amount or the money from the houses. Okay. But the condition is he won't steal. He cannot steal from adjacent houses. That is, if he steals from 0, he cannot steal from house 1. Okay, if he steals from house 1, he cannot steal from house 2. Okay, and so on. Okay, so this is a condition. Okay, now there's another thing that we need to consider these houses, right? In a circle. That is what for the last house, like it is like this. For example, 1, 2, 3, 1, right? 1, 2, 3, and 1. It is like this. 1, 2, 3, 1. Okay. So he cannot also steal. If he steals from the first house, he cannot steal from the last house, like from this particular last house. And if he steals from last house, he cannot steal from first house. Okay. So this is a condition. So this is an extension to yesterday's problem. Okay. So we are going to use the same solution to solve this problem. Okay. The only thing is we'll tweak the solution a bit. Okay. So what we are going to do? So now, for example, now in order to maximize, right? In order to the thief can steal, right? So what we can do is for each house we can have two choices. The thief can steal from this house in one choice. The thief will steal from this particular house in another choice. The thief will ignore this particular house. Okay, the thief will ignore this particular house. So for example, if he chooses to steal from this house, then he cannot steal from this house. He can steal from this house. Okay, if he chooses to ignore this particular house, he can or he will steal from this particular house, right? He'll steal from this particular house and he cannot steal from this particular the adjacent house. Okay, and so on. So we'll have at each house we'll have two choices, either to take or consider or steal or not steal or not steal. Let's call it not take or not steal, steal or not steal. Okay, now so in each, right? So let me write the code. You'll understand better. So what we're going to do here, we'll implement the max loot function. Int max loot. Okay. And what we're going to pass in this max loot array, and we'll also pass int n equal to array dot length. Okay. And what we're going to pass, let's say we are going to pass from 0. Okay, the house 0. Okay, that is the thief will steal from house number 0. And we need to go till, okay, let's write it n minus 1. Okay, n minus 1. So we have an array as a first, then int I, the house index, that is the house number, and int n. Okay. Now what we're going to do, we are going to have two choices here. We have to make two choices, right? At each house, take or not take. So what are we going to do? If we take, that means we want to steal the money. So where is the money? R of I represents the money. We'll take the money and we'll loot the next house, which will that next house will be I plus 2. Why not I plus 1? Because the next house will be I plus 2, because I plus 1 is adjacent and he cannot steal the money from the I plus 1 house, which is adjacent one. That is why I plus 2. And n will be as is. Okay. And for example, another choice will be to not steal, right? So we won't consider this arrow of I because he's not stealing. He's not stealing the money. He's ignoring this particular house and will go to the next house. He'll steal from next house in this way. And what we want is we want to return the math.max. We want to return the max of either steal or not steal. It may happen, for example, it may happen that here it was 1, 2, 3, and 1, right? It may happen, for example, in one choice, he stole from this particular house. In another choice, not take, not take, he didn't steal from this house. He stole from this house. So it may happen at the end. At the end. For example, let's say he stole from this house, then from this house, right? From this house, right? and in another choice, he stole from this house and this house, this house. For example, let's say here it was 2. Okay, here it was, or let's say here it was 4. Okay, here it was 4. So in take, right, in this particular choice, he was able to steal this house and this house, which was 1 plus 3, 4. And in not take, he stole from this house and this house, which is 2 plus 4, 6. So even if, for example, for a particular house, he made the choice to ignore, to not take, not steal from the house, still he got maximum. So it may happen from this path, we may get maximum, right? That is why not take. Okay, that is why max between take and not take. Okay, and here what we're going to do, if I is less than n, if I is less than n, that means we have reached the end of the array, we have to return 0. Okay, we have to return 0. Okay, so this is the pseudo code, or maybe this is half-baked code now. So here, since the array is cyclic, right? So we want to make sure, for example, if the thief is stealing from the first house, which is the house number 0, he cannot steal from the last house because those first and last house are adjacent. So we will go till second last house. Okay, we'll ignore the last house. And another case is case number 2. He won't steal from the first house, he will steal from the second house. And he can easily go till the last house, right? Because we are ignoring the 0th house. Okay. And what are we going to do? Final return, whatever is the max out of case 1 and case 2, we are going to return that. Case 1 and case 2. So I hope you're getting this. Now, the code is still incomplete, sorry. Let's compile this and show the C++ code as well. Let's submit it. Now it will pass for some 10 test cases and then it will fail. The reason being, we'll get a TLE. Okay. See, we got a time limit exceeded. Why? Because the time complexity here is exponential, because at each element we are making 2 choices, either to take or not take, right? So the time complexity exponential. So we want to optimize this. So how we are going to optimize this? We are going to use memoization in order to optimize this. Let's see how memoization comes into play. N plus 1 we are going to do, and we will fill this array with -1, right? And we are going to pass this to the function max loop int dp here, right? We'll also pass the dp in the function calls dp. Now what are we going to do? For a particular n, for a particular house, for a particular, sorry, not a particular, for a particular n, for a particular I, we're going to store the value. Okay. Okay. Because it may happen that in some other case, right, when we are doing take, not take, right, at each house. So it may happen that we have come to that house again. So let's store whatever was the value for that particular house till now. Whatever is the outcome of take or not take, let's store it. Okay. So we have stored in the dp array. Now we are going to make the same check here. If dp of I is not -1, right? Initially we had initialized dp with -1. But if it is not -1, that means we had come to this occurrence of I. We had come to this occurrence of I. So we have already stored the value. We have already processed the value. So we will simply return from here. So that again the 2 calls are saved. Take and not take are saved. Okay. So we will save some time complexity. We have done some optimization, we can say. Okay. Similarly, what we are going to do? We are going to pass in this case 2 as well. The same will initialize to the dp with -1 again, and we'll pass here. Okay. So with this, it is optimized now. We have done recursion and memoization, which is what? Which is top-down approach of dynamic programming. Okay. So let's submit this. Now I think it should not give us TLE. Yes, all the test cases are passed. Thanks for watching. Please subscribe to the channel, like the video. Okay, let's quickly see the C++ code. It's almost the same. So here what we're doing here is we are taking the size, and then we are taking dynamic array of n plus 1. We are looting the first. The thief is going to loot the first house, which is 0th house, and he'll go till the second last house, right? He cannot steal the last house, because otherwise 0 and last house are adjacent house. Then again we are reinitializing the dp array, and here we are looting the second house. The thief is looting the second house, okay, which is house number 1, and he'll go till the last house. He'll steal till the last house. Now here's the base condition. If is the array I goes beyond n, that means n return, we have to return 0. If it was all for a certain house, if it was already computed, right, the max amount stolen for I house. So we'll return from here. Otherwise, we'll make two choices. Take to steal. So here we are stealing the amount. Here we are capturing the amount. And again, the next house would be I plus 2, or else ignore that particular house and move on to the next one. So and then finally take the max out of the two and return and store in the DPI. Okay. So thanks for watching. I'll also attach a code in the description section. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.